GPT-3 was brilliant. It could write essays, code, and poetry. But ask it to help plan a birthday party and it might give you a recipe for something illegal. The model was smart, it just wasn't aligned with what humans actually want. Every ChatGPT-like model goes through 3 stages. Stage 1, pre-training, read the entire internet and learn language patterns. This takes 6 months and $1 billion. Stage 2, supervised fine-tuning with about 10,000 examples. Stage 3 is where the real magic happens, alignment. The first step in RLHF is collecting human preferences. You show annotators 2 responses to the same prompt and ask, which is better? Do this thousands of times and you get a data set of chosen and rejected response pairs. Step 2, train a reward model. This model learns to predict which response a human would prefer. It takes a prompt plus a response and outputs a score. The training objective is simple. Make sure the chosen response scores higher than the rejected one. Step 3, optimize the language model using PPO, proximal policy optimization. Generate a response, score it with the reward model, reinforce high-scoring behaviors, and discourage low-scoring ones. Repeat thousands of times. But there's a critical constraint, the KL divergence penalty. Without it, the model would learn to hack the reward model, producing gibberish that scores high but makes no sense. The penalty keeps the model close to its original behavior. Here's the full RLHF pipeline. Human preferences feed into a reward model which drives a PPO training loop, generate, score, update, repeat, all with a KL constraint to keep things stable. The result? An aligned model, but RLHF is hard. It's expensive, thousands of human annotations at $10 to $50 per hour. Its unstable PPO training is notoriously finicky, and you need 3 models in memory simultaneously. For a 70 billion parameter model, that's 420 gigabytes of GPU memory. Enter DPO, Direct Preference Optimization, published in 2023. The key insight? You can skip the reward model entirely. Instead of training a reward model and then doing RL, you directly optimize the language model on preference data with a special loss function. In practice, DPO is shockingly simple. Load your model, load your preference dataset, and run a standard training loop with the DPO loss. No reward model, no RL loop, no PPO nightmares. That's it. Where does preference data come from? 4 sources: human annotation, expensive but highest quality. AI feedback, use GPT-4 as a judge. Implicit signals like user upvotes and regeneration requests. And existing open-source datasets. Anthropic took a different approach with constitutional AI. Instead of human annotators, the AI critiques its own responses based on a set of principles. Generate, self-critique, revise, then use the original and revised pair as preference data for DPO training. Here are the practical takeaways. RLHF transforms smart models into useful ones. DPO is the right choice for most teams, 95% of RLHF quality at 10% of the complexity. And invest in quality preference data, not clever reward functions. 1 epoch of DPO training is usually enough.